Hey everyone, welcome to the April Ask Tom Database Security Office Hours. My name is Richard Evans. I'm your host. I'm a Oracle Database Security Product Manager. I'm joined by my friend and colleague and admirer of my blue shirt, Mr. Alan Williams, Product Manager, Senior Principal Product Manager, who covers TLS, authentication, authorization, RAS, OLS, all sorts of. Alan has everything. So,
and please indicate your thumbs up or thumbs down on Rich's blue shirt. Getting sick of seeing that.
It's a great shirt. This call is being recorded. We will make this recording available to you a few days, a week or so after the event, so you can see it. We've got about over 3 years worth of recordings available out there on bit.ly/AskTomDBSec. If this is your first time joining us, thank you for joining us. This is the monthly Database Security Office Hours we hold on the second Wednesday of every month at 10 a.m. U.S. Central, so that UTC, those international times, do adjust depending on the time of the year. But we hold this one every time at 10 a.m. U.S. Central headquarters time. There'll be announcements, general presentation, and then Q&A. You can ask Q&A on anything. We'll do our best to answer. If we can't answer, we can chat offline and get back to you on it. Okay. Announcements. I try to put everything we talk about into this GitHub repository that I'll include in the chat here. That gives you access to these links, notes, Micro support notes, things that we're going to cover, so you don't have to try to write them down or take a screenshot or anything. You'll have access to it. So that QR code takes you to the GitHub repository. There's a bunch of links out there for this month and then probably the last 8 months or so as well. As usual, we're going to talk just patches are coming out here. Quarterly patches get released middle of the month. Make sure you're staying up to date as much as possible on these patches. If you're using real application clusters, RAC, then you have the opportunity to use fleet patching and provisioning. So take a look at fleet patching and provisioning as a tool to improve your patching and deployment process within your environment. Check out Mike Dietrich's upgrade blog. Mike always has a lot of good stuff out there on how to patch, how to upgrade, how to stay current, and how to do it in the most effective means. We also have got a Micro support note out there on migrating from traditional to unified audit. You might have seen the 23C beta developer release came out on Monday, I think it was. As we move toward 23C, we're de-supporting traditional audit. So we want you guys to be familiar with unified audit, know how to utilize it, take advantage of some of the new capabilities, which says context, component, top level, or exceptions there. There's a Micro support note that can kind of help you move that traditional syntax to unified audit syntax. It's very rudimentary, very basic, because you are going to have to understand what you want to do with auditing, what you're trying to do. So it's a good opportunity to reevaluate what your audit goals are and whether you should be collecting that data or not, or whether you can refine it with unified audit. DataSafe has some new enhancement that just came out yesterday. We're going to do a DataSafe Ask Tom event either in May or June, so I'm not going to talk too much about these, but for new customer tenancies, DataSafe is auto-enabled. We've got some touring kind of guide capabilities there for new users. Updated masking policies with the sensitive data models. If you've got password user profiles, you can see like who's assigned that user password profile on this target or this database or across all of your databases that DataSafe is monitoring. If you've got some databases that you want to override that global paid usage fee, maybe they're PCI databases or maybe the other way they're dev databases and we don't really care, you can override some of those global features or global settings. And then if you're using Exadata Cloud at customer or non-standard ports, you can take advantage of DataSafe with support for custom ports. Maybe it's 1522, 1526, whatever port you use. You can do that with Oracle DataSafe now. And then the thing a lot of folks are excited about is kind of the tiered pricing that DataSafe has introduced. So depending on the number of targets, right, that tiered pricing goes down as you deploy and you register more targets with Oracle DataSafe. Documents today related to TLS. I tried to collect these My Oracle support notes. There's a bunch of them. There's a lot of them. These are the ones that I thought would be most relevant for you today. And remember, I also put those into the GitHub repository as well. So I'll share that again in the chat. So you can go to that GitHub repository or that QR code, and you can take a look at those My Oracle support notes. Lots of things to troubleshoot. We're going to give you some troubleshooting tips at the end of the presentation, kind of give you a guide on what we see most often. Database security live labs are really still the best place to get your hands on Oracle database security capabilities. You can use that QR code. You can Google Oracle Live Labs. We've got over 40 database security related live labs out there, and more than half of them you can do on our dime. So you can run them as a green button lab that run on LiveLab's sandbox. And so then like, okay, I can run this, I can blow it up. Oracle will take care of it for me. You're not going to hurt anything. So experiment with that. Then what's really exciting is just on Monday, we released a new live labs focused on this one-way TLS that we're going to talk about today. So you can go through the lab that I'm going to walk you through today, and you can get your hands on how to do this. So there's a QR code to that lab. You can go to Live Labs and you can just type TLS and you'll see it in the drop-down list of, successfully protect your database communication using one-way TLS. We plan on adding more labs out there too, mutual TLS, maybe certificate authentication, some stuff like that. So really exciting to see this out there. Right now, it's only out there as a run in your own tenancy. In a couple of weeks, it'll be out there as a green button lab, so you can run it in our sandbox as well. But gives you an opportunity to kind of kick the tires on that. If you're in Tokyo, London, Sao Paulo, or anywhere near there, there's some free training coming up where you can get out there to this database world events that we're hosting. Take a look at that. Product managers are going to be there. It's a good opportunity to meet some of maybe your colleagues or peers, or have a one-on-one conversation with Oracle developers, Oracle product management, get to know what we're doing within the database. So we've got 3 coming up here. Actually, hey, that Tokyo one is today. That's cool. That probably already happened, didn't it? Huh? So yeah. If you want to be a part of the 23C beta, there's still time. We're doing beta 2. You can go to tinyurl.com/Oracle beta, or take a screenshot of that QR code. 23C is the next long-term release of the Oracle database. Pretty exciting stuff there. And as you've probably already heard, if you haven't, it's exciting. We've released a free developer release that's out there at oracle.com/23C free, where you can download the Oracle Virtual Appliance, the OVA. You can install it on your own Oracle Linux 8 environment as an RPM, so you can get your hands on a lot of this new capability there. So if you're developing an application, you are a developer, or you want your developers to have access to this, they've got pretty much every feature available within the database available to you in this Oracle Database 23C free developer release. It's cool stuff. It's neat to see that we're releasing that. We're getting that out there in developers' hands. All right, Mr. Williams, it is over to you here, sir.
So welcome. Another kind of back to basics type presentation on security. We haven't really, Russ has talked about Kerberos in the past. This isn't authentication. This really is about encrypting your TLS, your network with TLS. It's encrypting your network is just as important as encrypting your database, your data at rest. The assumption is that your hackers are inside, so you've got to really secure things inside the data center as well. So client-server communication is important to encrypt, and TLS is the standards-based approach to doing that. So my name is Alan Williams. I've been with Oracle for 18 years, which sounds like a long time when I said it. The first 9 years been with the Oracle National Security Group on the consulting side, working on U.S. national programs. And then the last 9 years with the database security group as a product manager. But not just those 18 years, but pretty much my entire career has been one way or another related with security. All right, so let's jump into it. We're not going to cover everything about TLS and the Oracle database. We're just going to skim the surface on really the most common use case here. And we could just mention the network encryption standards that we use, some of the utilities that are available. And kind of the meat of this is kind of the various decisions and trade-offs you have with TLS. You know, what you want to think about when you're encrypting your network. And then we're going to go through an example. I got the pretty picture version of setting up a one-way walletless TLS connection, and then Rich is actually going to show the hands-on the actual demo of the same thing. Things we're not going to cover is how to do TLS for outbound connections from the database to other services like OID or AD, database links, rack data guard. And TLS can also be part of an authentication mechanism using your PKI certificates for end user authentication, but we're not going to cover that in this one. This is purely about encrypting the network. All right. The standards, we got obviously transport layer security TLS, that's an IETF standard. TLS 1.3 is the latest standard. 1.2 is still acceptable, it's not deprecated. And those, since 23C has been released, I can mention that those are the two protocols that are supported in 23C. We have deprecated 1.0, 1.1, and SSL in the past. And so we have desupported with database 23C. We're still working, evaluating if there's a possibility of backporting TLS 1.3 to 19C. It's a large architecture change, and it may not be possible. So we're still working on that, and we'll let folks know later. The TLS will be using what we will need to authenticate the server, and to do that, we use the PKI X509 certificate. And that's used to create that, to work on, get the symmetric key that's actually used to encrypt and decrypt the transmissions. And that certificate, that X509 certificate, has some identity information for the server. And that certificate is used to authenticate the user. When we talk about certificates, the user in that context can be a resource like a database server or a client or a user. So when we say user, it's not just a human user in this case. Next to the utilities, what Oracle ships is something called ORPKI. It's a command line tool, and it helps create wallets, and this is your management for certificates. It helps create certificate signing requests, importing, adding or exporting certificates, things like that. There's other wallet utilities we have, MK Store, which manages the secrets inside of a wallet, and then Oracle Wallet Manager. That was a visual GUI tool that we used to manage wallets, but it's we're migrating to just using ORPKI and MK Store at this point. So OWM has been desupported with 23C. We deprecated in the past, and now it's desupported with 23C. OpenSSL is another command line tool, and I think Rich will show some interesting things you can do with OpenSSL as well outside of ORPKI. Okay, so the first decision you can make is, we provide a out of the box Oracle protocol called native network encryption NNE, or TLS. Another decision you have to think about is, if you're using certificates, who's going to sign it? Is it going to be self-signed within the organization, or is this something that's going to be a common root signed by some company like a DigiCert or a VeriSign or Symantec? You decide whether it's going to be a one-way, which is a regular. When you say TLS, it's one way, or is it going to be a mutual TLS, or it's both sides are authenticating to each other, and you're going to be using a client with or without a wallet. All right, so those are some things we'll get a little more depth here. So NNE is the Oracle protocol. We obviously it's not we use standard crypto libraries underneath it, but it's anonymous protocol that Oracle implements to make it extremely easy to set up encryption between the client and server by setting a parameter. There's no key certificate exchange that's minimized, so it's simple to do, but it provides encryption only. There is no authentication. It's because of that. There's always a possibility of the person in the middle attack. But this makes it very easy to encrypt the channel for just basic capabilities there. TLS is our standards-based implementation for encrypting the network. If you're working with a compliance regimen, most of them will require a TLS and may enforce a TLS version. So as standard-based, it's an authenticated connection. The bare minimum, it's server-based authentication. It's kind of like HTTPS for your browser, where the server authenticates and the client says, "Okay, yes, it's a valid trust certificate and it's a valid website." This may require a client wallet. It all depends on how you on your requirements and your platform sometimes. All right, self-signed root certificate or common. What is a root certificate? That's the trusted PKI certificate key that signs all your certificates underneath, and that's an organization can create their own self-signed root cert that's recognized within the organization, or you could get a common certificate authority root certificate, and this is where you go to like a DigiCert or VeriSign to get them to sign your certificates. Of course, that's not free; that comes with a fee. But the neat thing with that is all those certificates from those companies, the root trust CA certificate, is already loaded into your client machines and your systems in the default trust store. And that could be, the Mac OS keychain, it could be the Microsoft certificate store, Linux store. And that's how your browser uses that to trust the HTTPS websites. If it's not in there, you'll get that pop-up saying it's not safe. Do you want to you want to accept it? Do you want to continue to go to this website? So on the other hand, you've got the self-signed CA root cert that an organization can use, or it could be just a division within your organization that decides to use it. You can create that, or a PKI can generate that easily, and but by default, it's not available in your client default trust store. This is something that you could elect if it's common enough within your organization. The IT department could provision that trust cert into the trust store when you provision a new laptop. But that's that extra step has to be taken. It's not automatically part of these trust stores. So here's when I open up the trust store on my laptop, I've got 65 certificates already loaded in there. You can see like the DigiCert. I mentioned DigiCert a couple times. It's what our autonomous database shared, or the autonomous data warehouse. When you get that PDB service, you can connect to it easily because it uses the DigiCert certificate root of trust, and that's already in your client wallet. So you can actually establish a TLS connection with it without having to download a separate trust certificate. So when you use a self-signed root certificate, a common root certificate, that's already available. That's something that's these are public certificates, and you get your server certificate signed by this service, and the wallet for the server will hold the certificate for the server and that's signed by the service, and it's got the CA root trust certificate as well, showing that that's what's signed the server certificate. On the client side, I hope you like the icon I picked for the trust store. This trust store, like you saw for example from my Microsoft Windows trust store, already has the trust certificate from these companies. So it already sees that. So when it has to connect to the database using TLS, the database will send back its server certificate as well as a trust certificate, and that's already matches. That should match one already have in the client trust store, and so the client can simply validate that and then go ahead and complete the TLS connection with the database. If you use a self-signed cert, this is something an organization may select to do. They create their own CA root trust, and that will sign the server certificate. The server certificate still needs to be signed. The server certificate is not self-signed. It's still signed by a root CA trust. The trust store on the client doesn't automatically have that. So one way or another, that self-signed CA root trust certificate has to get in there either by provisioning or by copying and importing into the client trust store. When the client connects, same type of thing. The certificates are sent back, and the client now, since if the CA root trust certificate is in the trust store, it can do the same validation, compare, and go ahead and connect. Another example is the TLS or the mutual TLS. So when you say TLS, it actually implies one-way TLS, but a number of times I will mention one-way TLS just to make sure that we're on the same page with that. And this is where there's a user certificate for the database server, and that gets sent to the client. I'm simplifying this from, you saw there's also a trust certificate that gets sent over. With mTLS or mutual TLS, there's a user certificate for the database, as just like before, but there's also a user certificate for the client. Now that could just represent the client in general, or it could be specific for the user, but in this that's where it gets into the authentication, the user authentication. But this is the mTLS, and both sides authenticate to each other. And client with and without a wallet. This is something new. Well, for the OCI Instant Client SQL Plus, this has been available about a year and a half now with the we backport this 19C, and with the JDBC Thin client, that's been available, I think, since database 12C with it working with the Java Trust Store. And client without a wallet, that means that instead of you can just use the trust store in your client to validate the certificates that's coming from the server. No wallet needed. No wallet has to be managed, and that just reduces the layer of complexity on the client side. When you're if you need to use a wallet, that means and it could be for one it could be a platform reason. It could be compliance reason. You may not be allowed to use a trust store, so you need to set up and use a wallet on the client side with the same certificates that the client can use. So those are some of the trade-offs, some decisions to make when you're looking to implement encryption in your database. So we'll go through an example TLS use case. We pull in some of the information that we talked about with the decisions. And the first main use case, the common CA root trust certificate. I've talked to a couple of clients recently, and I asked them specifically what they use. If they use a self-signed root cert in the organization, or if they use a common cert, if they paid for that service. And the last two I talked to, they said, yeah, they both started with the self-signed cert. Well, it was free, but they kept running into corner cases where it didn't work, and they had to do some extra work to get that working with the client. So what they ended up doing is go ahead with the service and implement the common CA and using that instead of doing the self-sign. But these are both options that are available. So we're going to talk about using a common CA root trust certificate, which means that that trust certificate is already available in the client side. You still need a server certificate that represents the server. And so what you do is you create the server wallet, you create a certificate signing request, a CSR. And that's sent, you can go to a website for these companies. They'll validate who you are, and they'll sign the certificate. So they don't just blindly sign anything. There is some validation that goes on from them. That's why they can, there's some trust there. Then in the wallet, you have to load the root CA trust certificate, any intermediate certificates, as well as a signed certificate for the database. And that's got the information like the host and the host name and the DN for the server. And the client requests to connect, that sends back the server certificate as well as the root trust certificate. The client looks it up in the trust store, so it validates it, and then completes the connection because it trusts it, because it matches the trust information it has in its trust store. Oh, by the way, that microphone's a listener. The listener and the database both have to generally use the same server wallet and the same certificate. Just making sure that folks understand that. All right, self-signed, very similar use case, but in this case, the first step you have to do is actually establish your CA root wallet, certificate authority root wallet, as well as a self-signed CA root trust certificate in the wallet. This is separate than the server wallet with the server certificate. You still need to create a server certificate and a server wallet, and when you do that, you got to create the server signing request just like before. That step doesn't change. You get it signed, and then you have the signed certificate in the server wallet, as well as this time it's a self-signed CA root trust certificate in the server wallet. That certificate, the self-signed CA root trust certificate, has to get into the client. Well, we recommend going into the client store, and it can be done in provisioning time, or maybe it has to be done manually by the user. Then the same steps: the client requests to connect. You get the certs back from the database server, and it looks it up in a trust store. And because the self-signed cert is in there, it can go ahead and validate it and finish complete the TLS connection. If you don't or can't use the trust store for the client, then you need to put that into the wallet. Now, in this, what happens is in the JDBC. The JDBC uses the Java Trust Store, and that works on every platform with the OCI and the Instant Client. This looking up the Trust Store works in Linux and Windows, but not the Mac OS. So the Mac OS, and you want to use SQL Plus or something else with Instant Client, you'll need to use a wallet on the Mac OS. So in this case, the trust certificate has to be put in a wallet. But then it works the same way. They request to connect, you get the certs back, and it compares it to the wallet information versus the trust store information. So some things with TLS. Now, we still, in general, we recommend storing the self-signed CA root certificate in the client trust store if that's what you're using. There could be some cases where you have to use a wallet, and even though it may not be a Mac OS thing, but it's it's just all your connections can then use that without having to deal with separate wallets. When you're rotating the server certificates, what you need to do, because they expire after 5-10 years, and this is something that you should practice periodically, so folks don't get surprised by it when the server cert does expire. When the certificate is close to expiring, you add the new cert to the wallet. The database server will recognize that. The database server doesn't have to be restarted. However, the listener will have to be restarted for it to recognize a new wallet. So I've got an enhancement request to not do that, but we'll see. I'm not sure if or when that can be done. And when you're using server specific certificates, then we recommend using DN matching, either partial or full, and we'll cover that in another TLS session, exactly how that works. That really ties in what the client is requesting, make sure that the certificate and the server it's connecting to is the right server. A couple other recommendations I don't have written here, but setting the TLS protocol. You could set the TLS protocol, let's say it was DB23C, you can set it for 1.3. We don't usually see people requesting to set it to the lower protocol. But what happens between the client and the server is that they'll negotiate the highest protocol and the strongest cipher suite to use. So there's really no need to set those unless you have some compliance things that drive you to set it. But if you set it, let's say 10, 15 years ago, you set something to TLS 1.1, because let's say that was the highest at that time. But now you're going to be upgrading to 23C, and you've kind of forgotten about that. You set to 1.1. You never upgraded to 1.2. And then you upgrade to 1.3, database 23C. That's not going to work until you change that protocol to be able to accept 1.2 or 1.3, or just remove that restriction. So it's something you got to keep in mind. Don't set the ciphers, don't set the protocols unless you have some compliance thing that drives you, forces you to do that. Otherwise, you do have to keep in mind on that as you're upgrading.
The demonstration will be based off of the LiveLab that we just released. And so, like Alan said, we've got tools within the Oracle installation to create wallet, to add certificates, to generate certificates. So we're going to use all of this with Aura PKI, the command line interface, to do this today. So we'll go through it. We'll do the signing. We'll create a root CA. We'll create a database certificate. And then we'll use our root CA to sign our database certificate. Like Alan said, this probably depends on the environment that you work in, whether you have your own, whether you use a DigiCert or a public CA. But this is an example of kind of how we can do it. Again, this lab is available to you now. It's available for you to run in your own tenancy if you want. So what you would do is you would come to, like, let's say LiveLabs, just Google Oracle LiveLabs, and you'll find it on here. If you do TLS, successfully protect your database communication using one-way TLS. And then right now, it's only the black button run on your tenancy. In a couple of weeks, there'll be a green button so you can run it on our Oracle LiveLab sandbox. But if you don't want to go through all that effort, what I'd recommend is come out to the lab, walk through it, look at it, see what we do. And then you can even come and download the scripts. So if you just want to see, like, well, I want to see what command Rich was running to do that, you can do a wget and you can pull down this TLS zip that includes all these scripts that I'm going to walk through today. Okay, so check that out. These are the scripts. I've already kind of pre-prepared, pre-created this environment for us so we can get through restarting the database to set the wallet root location or installing the Oracle Instant Client, which I'm going to use. So the first thing we want to do is we just want to see what our protocol is. So when I connect to this database using this PDB1 alias, I'm just using TCP, right? So if I ping it, you can see that I'm using protocol TCP. I'm connecting to this host, and I'm on port 1521, okay? So when we deploy this, when we create this environment, this is going to change to TCP-S, and then we're going to change our port to 1522. You could completely replace this non-encrypted listener with an encrypted listener, but I like to run both at the same time to show the difference. And then I also, may have some unencrypted connections out there that I can't get to right away. So I want to give them an opportunity there. Okay. So the first thing we're going to do is we're going to create our root wallet. So if we create our root wallet, then what we can see is we are going to create our self-signed certificate store. So what that looks like here is we've got this command here, add wallet. We're adding it to our root CA wallet. Our DN is something generic that I created, US root. But the important part of this is it says self-signed. So this is our self-signed certificate authority here. We're just calling it root. It could be an intermediate. You could call it whatever you wanted. And then our validity here is for 10 years. So 3,652 days. That's a long time. You can set that to whatever you want, whatever your auditors recommend or your regulators recommend. And then here you can see that I've exported the root CA certificate here. So this is what we would use in our certificate, our client-side trust store that Alan was talking about. This is probably the certificate that you would use, because if you signed all of the databases with this certificate, then you would just have to maintain this one certificate on your client machines. Okay. So now that we've got our root CA, let's create our database wallet. So we want to create our database wallet. And what we're going to do is we are going to add the root CA trusted certificate to it. So we create the database wallet here. Notice that I did not tell it to self-sign it. I don't want it to sign it itself. I don't want it to create any certificates where they're self-signed. I want to export it for signing. So here's my certificate signing request. This is what Alan talked about, that you'd maybe put in a website internally. He said you could do a lot of this yourself, but most customers find that they buy a solution that helps them maintain this. So you might take this CSR, navigate to an internal website, upload the CSR, fill out some information on what its purpose is, who the contact is, and then it'll generate the signed certificate request for you. So here is this certificate request. This is what I would then, upload maybe internally, or I would work with DigiCert to get a signed version. In our example, we can go ahead and sign it using our root CA. So we've created the root CA, we've created the database wallet, we've generated that certificate signing request. Now we're basically going to take that certificate and use the root wallet and sign it. So what we've done is we've created it, we've used the root CA. Here's our request, right? Our CSR, this is our request. And then our output certificate is generated here. And again, these outputs could have different validity lengths, right? So maybe we say, well, maybe the root CA is valid for 10 years, but each certificate for each database is valid for 3 years. Your choice there. Whatever your organization does, whatever your program, your client, your applications you use does. But here it is. And here's our signed certificate. So now this is the certificate we're going to use for our database server as well as our database listener. And so what we'll do is we'll import this signed certificate into our database wallet. So what I want you to see here is when we look at our database wallet, we're seeing that we have a requested certificate. Remember, this is the certificate request we generated. When we import the signed user certificate into our wallet, it goes from requested certificate to a user certificate. So now it's a valid certificate. So when we connect to it, we should be able to trust it within our organization. Okay. All right. So we've done that. Now what we want to do is we want to deploy it. So we have to deploy it for our database server, which is that wallet root location. We want to deploy it for our listener as well. So what I will do is I will put it in a common directory here for the listener or for this OS user to go access. For the wallet root, I'll also copy it to the wallet root location of this pluggable database. So this is PDB1. This is the global unique identifier, the GUID for my PDB1 database that I'm currently working with. And so I need it in both locations. Now, if you look here, it says Etsy Oracle Wallets Oracle, where I've created that. So this will be the OS user who runs the listener. That's where you'll store it. So this default location that Alan has spoke about, Etsy Oracle Wallets, and then it's the username that is going to connect to the database or run the listener or run the Oracle processes. By default, mine is Oracle. Maybe yours is Grid. If your listener comes out of the Grid infrastructure, you would put that in Oracle Wallets Grid instead. In my case, I don't have that separate user. I've just got a very kind of rudimentary basic setup here, but just keep an eye on that. And that is documented there. So you'll see it in the documentation, kind of same thing on a Linux if you're not using the trust store. And then that case on Mac that Alan was talking about, where you'd either have to specify the location where the wallet is or put it in a kind of a standard directory there for you. Okay. So we've got our wallet out there. We can see that, we've got this user certificate and everything out there. So we're good there. And now let's see. Now what we need to do is we want to set it up to where our SQLnet.aura is going to have this one parameter because I want to set it to be false. So it's either TLS or mTLS. In this case, I want to use just TLS. We're doing no mutual TLS here. And like Alan said, previously I'd specified like the cipher 1.2. Well, when 23C comes out, then that's a parameter that I have to go track down and then change. The database will automatically negotiate starting with the highest level. So it'll start with 1.2 in 19. In 23C, it'll start with 1.3 and it'll work its way down there. So you don't need to set any of those parameters unless you have an organizational or compliance need to do that. I'd recommend just kind of leaving those alone and using as few parameters as you can and letting the default work for you. So now what we're going to do is we're going to add an entry to our TNS names file. So we've got our PDB1 and it's listening on protocol TCP. Now I've added another alias here, PDB1 TLS, just so I can kind of see the difference here. And you notice the protocol is TCPS. So this is our expecting TLS connections to it on port 1522. And then finally, what we're going to need to do is update our listener, right? So our listener is going to go to the default location. I didn't specify any wallet location in here. So it'll go to that Etsy, Oracle Wallets, Oracle as the OS user location. It'll look for its wallet files. The only thing I've specified in here is that client authentication is false. And I've told it to start listening on TCPS for port 1522. So now I'll have two listener ports going, 1521 and 1522, and we'll see the difference between those two in the next step. All right, so if we just test the original connection, we can see here that when we connect to our databases system, TCP, standard, nothing has changed there. When we connect to our database using TCPS, we're going to see that this protocol is now using TCPS. So this alias is listening on TCPS. This connection is encrypted. We can look at the details on that and get some trace information on that if we want. But so far, so good, right? Easy kind of use case because I'm on the database as Oracle. I'm running SQL Plus as Oracle. The listener's running as Oracle. The database is running as Oracle. Everything is Oracle. So I just have to kind of worry about that one scenario at that point in time. Let's expand this a little bit and say that we've got our database administrators who are on this system too, and we want them to use TLS when they connect to the database as well. So we'll create a separate user here called DBA Dan. So we'll user add DBA Dan. This is our operating system user that we're going to connect as. I don't want to open up any permissions on the database home for Dan to use SQL Plus or anything. So what I'm going to do is I'm going to install the Oracle Instant Client there. I'm going to get those RPMs, and I've already done that just for ease of use. So Dan can utilize this 19.18 client to connect to the database. And we don't have to worry about opening any privileges on that Oracle home on the database server. Now what Dan needs and every other user needs is, let's say we've got our TNS names. So Dan is only going to know about this TLS connection. He can probably guess that there's a listener running on 1521, but that's okay. We'll just give him that one alias. And now we're going to create our SQLnet.aura for Dan. Doesn't provide a wallet location, only tells us that our SQL client authentication is false here. And then I'm going to connect to DBA Dan. Now I'm going to set the TNS names admin so we know where to get this information. This is where I've stored my my TNS names and my SQLnet.aura. Now this is going to fail. I expect this to fail when I connect because I've skipped a step intentionally. So what's going to happen is you're going to see this certificate validation fail here. So certificate validation failure, I've not provided a location for where that certificate is. The SQL Plus client goes and looks at the SQLnet.aura and says, you didn't tell me where to get it, so I'm going to go to my default. My default is to go look in Etsy in this DBA Dan directory. There's nothing there. I'm not really sure what to do. I looked in my Linux trust store. I didn't see anything there. I can't make a connection here because I don't have that certificate. There's no validation that I can do there. So as Oracle, what we'll do is we'll deploy that certificate. So what we're going to do is install it into the Linux trust store. So what we've done is we've exported that root CA. So we've got this root CA file here, and we are going to install this for all users within our organization on this system to be able to access. So if your company deploys lots of Linux databases, they could pre-deploy this, like Alan talked about on Windows. They could pre-deploy this in their Linux installation. So the organization's root CA is out there. And then when Dan makes that connection next time, he's going to be successful because the SQL Plus knows where to go look for that by default. So let's set our TNS names admin directory again. And now we can connect. Now we want to verify that Dan is using TCPS by running just a syscontext command here to look at the network protocol. And we can see that he has this out there, and that is how he's connected. So very, very simple one-way TLS communication utilizing this root CA that's stored out there. So now let's do this on Windows. Alan showed you a screenshot of what his Windows environment looked like. This is just a Windows virtual machine that I have here. When I try to connect as PDB1, it'll connect. And let me grab my query again. Again, TCP. So same setup here, just on Windows. When I try to connect as system using the TLS connection, I get that same certificate validation failure. So I want to do the same thing here. So what I'll do is I'll look at this root CA, and let me just show the contents of it. Oops, I'm DDA Dan. Let's get back as Oracle. Here's our certificate. I'm going to take this certificate all the way down through the end certificate. And I'm going to come to my Windows machine, and I'm going to open our trusty notepad, and I'm going to paste this in here. I'm going to save it, and I'm going to call it org-root-ca.cert. And I'm going to change this to all files because Windows loves to add its own extensions to things. So it would add .txt to it and be annoying. Save that guy. Now within here, if I wanted to add my own certificate, I could go into Manage User Certificates. This is that cert manager that Alan was looking at. When I look at mine, I'm going to go to root certificate authorities here. I'm going to expand this. He had 66. He's way more important than I am. I've only got 33 certificates on here, but I'm going to add a 34th by importing this certificate. So when I choose to file, import it, it's going to ask me where to place it. I'm going to place it here. And then it's going to say, well, hold on a second. We can't validate that. That's okay. Like, this is ours. This is our internal CA that we trust. Your organization probably has a better process than my little Aura PKI commands, but you understand the root versus the database server certificate as well, and the difference there. But I'm going to import this. That way, any certificate that I generate within my organization that's generated or signed by this root certificate authority should be trusted by my Windows machine. So let's import it. Import was successful. If we scroll down here, you can see that we've got this root. Should have given it a better name, huh? But root, and then it's valid for our 10 years. So 2033. It's going to be valid past Alan's retirement. So I'll have to remember to delete that thing. All right, now when we connect, we're connected without any error. And if I can up arrow here and look at the network protocol, we can see that we are connected with TCPS. If I disconnect and I delete this certificate, we no longer trust it. Next time I try to connect, certificate validation failure, right? So very easy to add this root certificate to our system. How it works in your organization, I can't necessarily say, but this gives you an example of how to do simple one-way TLS. Now let's talk about some troubleshooting steps that we have here. Typically, when you're connecting to the database and you're going to get a SSL connection closed, what I like to do is I want to enable this connection tracing within the SQLnet.Aura, whether this is on the database server like it is in this example, or it's on the client. I want to see what's going on there. So I want to see the server trace first. I want to look to see, I'll set that maybe to support. Maybe I don't give it any additional information, but there's a lot of options that you can set along with this one parameter. But if I go look at that trace file, what you can see here is that it can't find the wallet, right? So the database server is going to look at the wallet root location in 19C, and it's going to say, well, I can't find it there. So I'm going to fall back to the other location, the Etsy wallet Oracle OS user that runs the Oracle binaries. And if it can't find it there, it's going to throw in an error. So if you set the tracing to support, you can get some good information here and identify what's going on within your TLS connection. In this case, I need to make sure that that e-wallet and c-wallet are available and readable in that wallet root directory. And again, that 9623 number is the global UID for my pluggable database. So I'd have a directory under each of these wallet root locations, that CDB1 location for each of my pluggable databases. And inside that TLS directory is where I would store that C-wallet, e-wallet files. Another thing that goes on, let's say with the listener, is maybe I want to trace the listener. So within the listener.aura, I will set the trace level listener to support. And then I can see here that the wallet open failed. So it doesn't know where to find its location. So the listener itself says, well, hey, I need a wallet too, man. Where do I find my wallet? So typically, like I said, it runs under the default location is that Etsy, Oracle wallets, Oracle for me, or if your listener runs as grid, it could be under grid, or you can set that wallet location parameter in the SQLnet.aura and tell it where to go find that wallet location, okay? TNS ping, you might get an error with TNS ping. So if I did a TNS ping on this PDB1 TLS, I might get back this error that says protocol adapter error. Generic error doesn't really help us understand what's going on there. It also doesn't give away any information either. So it's kind of a double-edged sword there. But if we set the SQLnet.aura and we set this TNS ping trace level to support, then we can take a look here and see that we've got a certificate verify failed. So maybe that certificate is expired. We need to replace it with a new one. So you can look in that trace file and get an idea of what's going on within your environment. Now, remember, kind of three locations that you're going to have to trace, right? The client and whether it has access to that root CA, intermediate CA, server CA, however it's going to connect. The listener, does it have access to that wallet? Does it have access to its wallet and it knows about its certificate? As well as the database processes, does it have its files in wallet root or that default Etsy location? Okay. One of the cool things you can do is use OpenSSL to test as well. So here's an OpenSSL S client connect to my TLS port. And what we're going to see here is that it tells me that my certificate has expired. So that's pretty handy to be able to go and just run this TLS command and connect to it. Like, for example, let's do that real quick here. So if I'm back on my database server here, and I put this command in here, you can see that it spits out a lot of information. So it provides like the certificate to the database. It tells me information about it, TLS 1.2. If you're using 23C and you generate the certificate, you'll see it says TLS 1.3 there. So we can get some good information off of this by using this connection. So if you can't make this connection to your TLS port, then you probably have something going wrong with, the listener and its wallet or certificates or the database and its wallets and its location. Let's see what happens when I do 1521. It tells me, I don't know what to do, man. There's no peer certificate, no client certificate. It does not appear that TLS is running on this port. There's nothing that I can exchange here or any information I can get out of that. So we can see that we're not utilizing TLS on this 1521, kind of an easy, nice little troubleshooting step that has helped me as I've built this. Invalid or unable to find the certificate on the client. Again, I like to take a look at the Oracle client. I might set the client level and then the client file information. And I can see here that we're getting a certificate verification failed. I can also take a look at, what certificate that I'm using to connect to the database. So when it does work, I can look through this trace file and see what certificate it was that it used to connect here. So I can see that it was this US root certificate that I have here. And, it's for that DBSec lab VM. So cool stuff that we can get out of this. There's a lot of corner cases. There's a lot of different things you can do to troubleshoot TLS. I provided those My Oracle support notes early on in the announcements section. Those are available on this GitHub repository page that I have here. And so I'll paste that into the chat one last time if I can find it. Here we are. Okay. So take a look at that GitHub link there. I put those Moss notes out there, and then go check out that lab. Like, it's a cool lab. If you don't want to run it on your OCI VM or your tenancy, you can always just download that tls.zip file, look through those scripts, and then, rework them to work in your test dev environment that you have. Okay. Again, kick the tires on 23C too. So you can take a look at that and see TLS 1.3 on there. All right. Next month, probably going to talk about Oracle Data Safe. It's going to be on Wednesday, May 10th, coming up pretty early in the month. I think we're going to talk about Data Safe, maybe Key Vault, but I think we're going to do Key Vault in June.